Spring, Brevard County, Florida. A canal so choked with hydrilla and water hyacinth that the surface looked solid, like you could walk across it, and the water beneath had been gray-green for 11 consecutive months. A flatbed truck pulled alongside the bank, and workers and chest waiters lowered 10 West Indian manatees into that water one by one. Each animal, somewhere between 400 and 600 kilograms of warm-blooded, slow-moving appetite, dropping into a canal that had not known a grazer in years. Within 72 hours, the monitoring crew watching from the bank recorded something that had not been written into their observation sheets. The vegetation line had visibly retreated, not trimmed, retreated. I am Dr. Raymond Finch, and I have spent 40 years watching ecosystems fail and watching them return, and I can tell you, the moment a grazer meets the plant that has grown unchecked in its absence, what happens next is not gentle. Now, think about what that means for a moment. 11 months of mechanical intervention, herbicide applications, and manual clearing had moved that vegetation line by almost nothing, and 10 animals accomplished what the machines had not. Because they were not managing the canal, they were hungry. Dr. Elaine Marsh, aquatic botanist at the Florida Fish and Wildlife Research Institute, placed her first transect markers in 2022, expecting to document feeding pressure across a 6-week observation window, a standard protocol she had used on a dozen prior studies. She came back in 4 days and found her first marker had been grazed clean to the root. The hydrilla that had anchored itself across that section of canal bottom was gone, and the sediment beneath was exposed and pale, visible for the first time in nearly a year. A single manatee will consume up to 10% of its body weight in vegetation every day. Multiply that across 10 animals, and you are looking at somewhere between 400 and 600 kilograms of plant matter removed from the water column daily. Not as a management strategy, but as breakfast. Here is where the data stops being data and becomes something else entirely. Because what Marsh documented was not just feeding pressure, it was a behavioral sequence she had never recorded at this speed. The animals were working the hydrilla in coordinated passes, their prehensile lips stripping growth in overlapping arcs, like a mower run by instinct older than the canal itself. What Marsh could not yet explain, and what her field notes flag with a single underlined word, was why the animals concentrated on the deepest choke points first, moving toward light-starved zones where the hydrilla was thickest, rather than grazing the open margins where feeding would have been easier. That answer is coming, and it changes everything about how we think manatees interact with a degraded waterway. 10 animals, 1 canal, and 72 hours. And the field report already did not look like a feeding study anymore. It looked like a canal trying to remember what it was before the algae arrived and the grazers disappeared. From the highway bridge spanning Brevard County's restoration corridor, you would have seen exactly what Florida wanted you to see. A warm green shimmer, herons posed on the margins, the kind of postcard that ends up on a tourism brochure. Dr. Elaine Marsh saw something different entirely. In 2022, before a single manatee entered the target zone, Dr. Marsh spent 3 weeks running baseline surveys through the corridor, transect by transect, depth of reading by depth reading, and what she pulled back up from below the surface was a portrait of slow biological collapse. Submerged light penetration in the Brevard County corridor had dropped below 12% of surface levels. And 12% is not merely dim. It is below the threshold where native seagrass can photosynthesize at all, which means the bed was already converting from a living mat to a substrate for nothing. This is the part that made me stop and reread the field notes. The geographic scope of the damage was not a single troubled stretch. It was a system-wide pattern, and each location told the same story in a slightly different register. In the Brevard County corridor itself, light penetration had fallen below 12%. Native seagrass stopped reproducing, and the substrate began accumulating silt with nothing to bind it. Along the Kissimmee River feeder channels to the west, invasive mats had reached 94% surface coverage in the bond shallows. The zone beneath them had gone anoxic, and nothing with gills survived a full night there. In the St. Johns River, tributaries feeding the restoration zone, native eelgrass had retreated more than 70% from its documented 1980 range. 3 decades of contraction reduced to a map Dr. Marsh could hold in one hand. At the southern terminus of the target stretch, dissolved oxygen averaged just 2.1 milligrams per liter in the pre-restoration window, a reading that sits well below the 5 milligrams per liter juvenile fish require to survive until morning. 2.1 milligrams per liter. That number does not sound catastrophic until you hold it against what life requires. And then it sounds exactly like what it was, a corridor that had learned to look alive while everything underneath it suffocated. The corridor smelled like a slow drain. It registered as green on every satellite pass. The birds that perched on the margins were feeding on the margin's edge, not on anything below it. Because below it, there was nothing left to find. A green ceiling with no floor underneath. Now, if you were forming the thought that fertilizer regulation or mechanical harvesting could have addressed this without relocating large grazers into a managed waterway, that is exactly the assumption every agency budget meeting had made for the better part of 2 decades. Stay with this, because what the cost data behind that assumption actually showed is something the field reports document in uncomfortable detail, and we are going to walk through it precisely. By 1980, the corridor's native seagrass coverage was still measurable and mapped. By 2022, when Dr. Marsh ran her pre-deployment surveys, that same coverage had contracted by more than 70%. Not through a single catastrophic event, but through 4 decades of incremental suffocation that no single budget cycle ever had to own. What no mechanical program had ever produced, what no regulation had reversed, was a documented recovery in dissolved oxygen at the sediment level within days of a biological intervention. That is what Dr. Marsh's instruments were about to record. And the number that came back from the bottom of that corridor is the reason this study did not stay inside a regional journal. That number from the sediment, the dissolved oxygen figure Dr. Marsh's instruments pulled from the canal bottom, did not stay quiet inside a Florida database. It traveled because it arrived alongside 7 years of documented failure that the agencies involved had never been asked to summarize in a single place before. Before a single manatee entered that water, the canal had already been treated, chemically, mechanically, repeatedly, across 3 separate treatment seasons spanning the better part of a decade, with real crews operating real equipment under contracts that the Florida Department of Environmental Protection's own program records confirm. Each treatment cycle ran into several $100,000. Not a rounding error, not a pilot budget, but a committed expenditure of public money aimed at a problem that came back every time because the herbicide was killing the visible stems, while phosphorus from agricultural runoff kept the root systems flush with energy and ready to rebuild. Dr. Elaine Marsh, aquatic botanist at the Florida Fish and Wildlife Research Institute, made this pattern impossible to ignore in her 2019 monitoring report, documenting that hydrilla rebounded to near pre-treatment density within 14 months of every chemical application, a cycle that had repeated itself without interruption across every treatment season on record. Here is where it gets interesting. The treatment was never failing at what it was designed to do. It was clearing vegetation on contact reliably every season. What it could not do was close the nutrient budget. The phosphorus kept arriving. The canal kept feeding. The weed kept returning. The problem was not the chemistry. The problem was the math. Then 10 manatees entered the water, each animal carrying between 800 and 1,200 pounds of body weight, consuming vegetation at a rate approaching 10% of that mass per day, meaning a single animal was capable of processing up to 120 pounds of hydrilla, water hyacinth, and floating weed between dawn and dusk, and returning the following morning to do it again. 10 animals, no fuel receipts, no herbicide permit applications, no rebound lag, because the grazers came back at first light and the vegetation had nowhere to recover to. The operational cost differential between the 2 approaches, one measured in hundreds of thousands of dollars per cycle, the other in fish pellets and monitoring time, was not a marginal finding. You may already be asking why this took as long as it did. And that question has a documented answer that is worth sitting with. A water management subcommittee formally raised concerns in 2021 about animal movement risk and canal infrastructure compatibility. And those objections triggered a review process that held the project back by 14 months while the paperwork moved. The canal did not pause during that review. The hydrilla did not pause. The phosphorus did not pause. That 14-month delay, measured against the documented grazing rate of 10 animals consuming up to 120 pounds each per day, represented a volume of unprocessed vegetation that no single agency budget line had ever been asked to calculate. What Dr. Marsh's instruments recorded when the animals finally entered the water, what happened to dissolved oxygen levels, to light penetration, to the sediment layer itself across the weeks that followed, is the part of this story that moved out of the field report and into something larger. And that is exactly where we are going next. What Dr. Marsh's instruments recorded was not a gradual improvement. It was a sequence, one physical event triggering the next, each step measurable, each step verified in field notes that now sit in the Florida Fish and Wildlife Research Institute's archive. It started with the lips. A manatee's prehensile upper lip, muscular, split, independently mobile on each side, grips a hydrilla stem at the base and strips it clean in a single pass, the way a hand strips a vine, not the way a machine cuts a field. Precise, selective, repeatable 6 hours a day. Those two lobes of the upper lip work in overlapping arcs. One passes, the other follows, and the result is a canopy opening that no mechanical cutter has ever replicated at that spatial precision, at that depth, without disturbing the sediment layer underneath. Within 2 weeks of the 10 animals beginning their coordinated passes, those canopy gaps were wide enough that sunlight reached depths that had been in complete darkness for years. And that single physical fact changed everything beneath it. Widgeon grass, tape grass, species that Marsh's 2022 Transx had formally listed as functionally absent from this system, showing green shoots within 3 weeks of canopy opening, photosynthesizing in sediment that had received no usable light in half a decade. Not a transplant, not an intervention. A memory the substrate had kept. Then the oxygen numbers moved. Marsh recorded dissolved oxygen climbing from 2.1 to 4.8 milligrams per liter within 6 weeks of active grazing beginning. A shift that crossed the threshold below, which most fish species cannot sustain their metabolic function, let alone reproduce. You are probably wondering at this point whether the fish simply wandered in by chance, whether proximity to healthier waterways explained the timing. That question has a specific answer buried in Marsh's invertebrate counts, and it reframes the entire sequence. We are going to get there. Stay with this. By week 8, juvenile bluegill and largemouth bass had moved into sections of the canal floor that had been bare mud 56 days earlier, following an invertebrate base of aquatic insects and small crustaceans that had re-established in the newly oxygenated substrate beneath them. Great blue herons arrived on the margins at week 10, standing motionless in water that 70 days prior had held dissolved oxygen incompatible with any prey worth hunting. Snowy egrets followed. 2 species of wading birds, drawn not by restoration effort, but by the simple fact that something edible had returned to a place it had abandoned. 14 days of selective grazing by 10 animals opened a light corridor. That corridor seeded 3 weeks of native grass recovery, which drove 6 weeks of oxygen gain, which rebuilt an invertebrate floor, which pulled in fish, which summoned birds. A functioning nursery habitat assembled in under 90 days from a system that had resisted every dollar thrown at it for 7 years. The manatee did not restore this system. It ate the ceiling that had been blocking the light, and everything underneath remembered exactly what to do when the darkness lifted. What that means for the 74 other compromised waterways on Florida's monitoring list is the question the data is now forcing managers to answer. The plan was tidy, a 2.3-kilometer treatment corridor drawn in committee, filed with the Water Management District, color-coded on laminated maps that nobody consulted more carefully than the manatees failed to read. By the 10th week of the project, Dr. Elaine Marsh at the Florida Fish and Wildlife Research Institute sat down with her acoustic tracking data on what she would later call the most disorienting morning of her career, and found 3 transponder signals where no transponder signal was supposed to exist. Those 3 signals were broadcasting from a secondary feeder canal, connected to the primary corridor through a culvert that the original survey had categorized as too shallow for manatee passage at average tide. The animals had moved through it anyway, probably at a tidal high that gave them just enough clearance, following nothing more complicated than the next available meal. The secondary canal they entered fed irrigation infrastructure for a private agricultural operation. The landowner called the water district within 48 hours, not to complain about damage, but because the vegetation clogging his irrigation intake had been cleared so completely that water pressure in his entire system had climbed measurably, and he wanted to know who had authorized it. Nobody had authorized it. The project team had sent no one. The Manatees had simply followed the food. And that is the part I want you to sit with. Because what you are looking at now is not a management failure and not a containment breach. You are looking at a foraging animal doing precisely what 60 million years of evolution shaped it to do, indifferent to the permit boundary drawn across its habitat by people who had never been manatees. There was a second outcome nobody had modeled. The grazing pressure across the corridor was deeply uneven. Sections where the animals concentrated showed rapid, documented native seagrass recovery. Sections they visited less frequently saw invasive growth return and a partial rebound, producing a patchwork across the full treatment corridor that Marsh recorded in her 2022 field notes, not as failure, not as success, but as something she called a negotiation. You are probably asking yourself right now whether an uneven result disqualifies the whole effort. Whether a canal coming back on irregular terms is better than a canal managed to a uniform standard. That question is exactly what Marsh brought back to the research team, and the answer her data produced is where this story turns in a direction no one anticipated. Stay with this. Because the patchwork was not random noise in the recovery record, the uneven grazing had produced edge habitat, alternating bands of cleared substrate and residual cover that certain native fauna appeared to actively prefer over uniformly cleared sections. The negotiation, it turned out, had a structure. Marsh submitted her amended field report in late 2022, flagging the unintended corridor expansion and the patchwork recovery pattern to the Water Management District, not as a problem requiring correction, but as data requiring a new framework. A living animal does not graze according to a permit boundary. And the moment you accept that, you stop calling it chaos and start calling it biology at full scale. What the 74 other compromised waterways on Florida's monitoring list are now facing is the same question in a larger form. Not whether manatees can clear a canal, but whether the people managing those canals are prepared to follow where the animals lead. That answer is coming, and it is not the one the Water District expected. Dissolved oxygen at 2.1 milligrams per liter is not a canal in trouble. It is a system that has already ended and simply has not gone still yet, the way a fire holds shape for a moment after the fuel is gone. 10 grazers pushed that dissolved oxygen reading to 4.8 milligrams per liter in 6 weeks. Not through any intervention we designed, but through the oldest transaction in a wetland system. Appetite meeting, abundance inside a confined space, and physics closing the deal. That shift from 2.1 to 4.8 milligrams per liter is the difference between a body of water that suffocates everything trying to live in it and one that can hold a food web again. It is a number small enough to fit on a field tag and large enough to rebuild a living system from the bottom up. Dr. Elaine Marsh at the Florida Fish and Wildlife Research Institute had spent 7 years documenting that waterway's long decline, and 3 full treatment seasons watching herbicide applications failed to hold any ground they temporarily cleared. A slow, documented defeat she recorded, with the precision of someone who refused to stop counting. She told me that the morning she placed her first transect markers in 2022, she had calibrated herself for a 6-week observation window. She returned in 4 days to find the first marker grazed clean to the root, hydrilla stripped from the canal bottom, sediment exposed and pale beneath open water. What she had not prepared herself for, not in 7 years of field seasons, not in any recovery model she had built, was the morning she stood at the bank and watched a juvenile bass holding steady in the current over a recovering patch of tape grass, completely still, as if testing whether the world was safe again. She stood at that bank for a long time without writing anything. She had come to document a treatment effect. The notebook stayed closed. What the water did next is the part that made Marsh reread her own field notes twice before she trusted them. Native invertebrate counts at 3 of her 5 sampling stations had risen measurably within those same 6 weeks, documenting the base of a food web reassembling itself one trophic level at a time, following the grazers as they worked. You are forming a reasonable doubt right now, whether a single season of grazing can hold, or whether the vegetation pressure returns the moment the grazers move on. That answer exists in Marsh's monitoring data from the 14 months following the initial 6-week window, and it does not go where the skeptics expected. Stay with this: the water did not recover because we intervened more cleverly. It recovered because we returned the one thing that had been managing that exact overgrowth problem for roughly 6,000 years before we ever laid a concrete drainage edge along the bank. Drop your region and one species you have personally watched disappear from your area in your lifetime. And yes or no in the comments. Have you ever seen something come back that you were certain was gone for good? Because if the answer is yes, I want to hear that story. Share this with someone who still believes the damage is permanent because the evidence says otherwise. I'm Dr. Raymond Finch. I'll see you in the field. Along the Chesapeake Bay's tidal flats, a managed oyster reef restoration covering 35 hectares produced water clarity readings the Chesapeake Bay program had not recorded in that sub-estuary since 1987, a result that a single Maryland legislative subcommittee blocked from scaling for 6 years, citing commercial navigation depth concerns before those 35 hectares made the argument on their own. The unresolved question is whether oyster filtration alone can hold those clarity gains when nitrogen loading from the watershed upstream remains at its present level. And that is precisely what the next restoration season was built to answer.